Okay. So this video is going to start with number 23. It's for your homework problems. We'll be having a quiz over these problems, just a reminder. So let's see here, number 23 is on page 98. So again, if you're using this video to do your homework problems, it's best to try to do it on your own and then pause the video as I'm going through, and that will just help you learn more if you're trying to do it on your own. So number 23, we have a golf ball that rolls up a hill toward the golf hole. Assign the direction toward the hole as being positive. So if it's initially traveling at 2 meters per second toward the hole, it has a positive velocity. So the initial horizontal velocity is 2 meters per second, and it says it slows at a rate of 0.5 meters per second squared. Oops, there we go. It's on the screen. So if it slows, that makes the acceleration negative. So they didn't tell us it's negative, but they did tell us it has a positive velocity and it's slowing down. So I have to know in my head to put the negative. And then it does this for a total time of 2 seconds, and it's asking for the final velocity. Okay? And it didn't say anything about initial position, so I can assume that that is 0. Okay, so if you can complete the problem just knowing these variables, pause your video and see if you can figure it out. Remember, you're using equations 1, 2, and 3 on your equation sheet. Okay, so in doing this, here are the equations that I chose. To figure out Vx, I knew Vx naught, I knew A, and I knew T. So this was a good equation to use. Remember, when you're doing this on a test, you have to list your variables, the numbers, and the units, unless it's 0. 0, you don't have to list a unit. You have to show me the equation that you're going to use, and you have to rearrange the equation if you need to before you add numbers to it. Okay? We don't have to, so Vx naught, I'm just going to put a blank line here right here for Vx naught, and then for A times T, I'm going to put a cross. Okay, so every variable has its own apartment. It's upstairs and downstairs. Okay, so Vx naught is 2 meters per second. Remember, no slashes above or below the main line. So meters goes on top, seconds goes on the bottom. Plus negative 0.5 meters per second squared. Again, no slashes above or below the main line. And then times 2 seconds. Cancel out my seconds. Enter this into my calculator, and I get 1 meter per second. So at the end of 2 seconds, this ball starts here, and it's traveling up the hill at 1 meter per second. It is decelerating, so ultimately it's going to at some point either make it to the top of the hill or come to a velocity of 0 and then start heading back down the hill. Okay, so part B says to figure out the velocity at the end of 6 seconds. So we have 2 meters per second for our initial velocity, plus the same deceleration we had, but this time we're multiplying it by 6 seconds. When we put this into our calculator, we get a negative 1 meter per second. Okay, so at 2 seconds it was moving toward the hole at 1 meter per second, but at 6 seconds it had already slowed to 0 and it was heading back the other direction. Okay, and then on this one, I told you didn't have to do C, but I want you to do a position time graph, a velocity time graph, and an acceleration time graph. Okay, so as far as position goes, heading towards the hole is in the positive direction. So if we think about it, I'm going to put this on just so I can think about this through the position time graph. If this is the hole and you're headed towards the hole, and that's a positive direction, you must be starting on the negative side of the hole. Like this is west and this is east, right? So I'm headed toward the hole, so I start on the negative side, so I'm going to start down here. And I'm not speeding up, I'm slowing down, right? So headed east, slowing down, so it tells me to start here as far as the y-axis goes. but my slope represents the velocity. So it starts out kind of fast, but it ends up slowing down. So it would look like this. And that gets me to stop, and then I start back in the other direction. And so I start accelerating in the negative direction. Okay? So I started with this positive velocity, and then I end up with a negative velocity. Positive decreasing slope, negative increasing slope. Okay, that's kind of a tough one. We never made it to the hole, so we didn't even make it to this line. Okay, for my velocity time graph, I started out with a positive velocity, but it slowed at a constant rate to 0, and then it sped up in the negative direction. For my acceleration, it was headed in a positive direction and slowing down, and then it was headed in a negative direction and speeding up. So the entire time I have a negative acceleration. That's one way of looking at it. Also, the slope on this line tells me I have a negative acceleration. Negative slope, negative acceleration. Okay, so that's the end of number 23. Moving on to number 24. And let me check the time, because my video cuts out on me at about 7.5 minutes or so. So we're at 6.5 minutes. I'm going to go ahead and do one more problem on this video. Hopefully it doesn't cut out. Okay, number 24, we have a bus traveling at 30 kilometers per hour. It speeds up at a constant rate and of 3.5 meters per second squared. What velocity does it reach, Vx, 6.8 seconds later? So these are the things that I'm given, and it did not tell me anything about initial position, so I can assume that's 0 again. Okay, so I'm looking for Vx. I know everything in this equation, so I can use this equation and make sure you're putting everything in and showing your units. Okay, I'm not going to complete this problem. I want you to complete this problem. You got the answers. They're in Appendix C on my website. But I am going to put everything in here, and just looking at the units alone, whoops, I accidentally canceled out too many seconds. This second cancels out one of these, so there's still a S left. So I have meters per second here, and I have kilometers per hour here. Now if this were a test, I have a lot of kids that will just rush through here, and they will never pay attention to the units, and they won't pay attention to the fact that you can't add kilometers per hour to meters per second. But if you are paying attention to the units, this will remind you, oh wait, I can't do this because I can't add these two. So probably the easiest way, you're going to have to go back and convert this to meters per second so that it matches these other units. Convert that to meters per second, plug it in here, and then work your problem, and then you're going to come out with an answer in meters per second. But if you look at the answer in the book, it's in kilometers per hour, because etiquette says if they give you an initial velocity in kilometers per hour and they ask for a final, you're supposed to answer them in the same unit that they have given it to begin with. So you have to convert this, get your answer in meters per second, and then convert it back to kilometers per hour. Okay, stopping this video and starting a new one.